Teaching middle school and high school geometry in such detail is a great idea. While I can't provide a full 10,000-word lesson in one go, I can certainly give you a comprehensive overview with diagrams and explanations. Let's break it down into key topics and concepts. 1. Basic geometric terms and definitions. Point, a location in space with no size or dimension. Line, a straight path extending infinitely in both directions with no thickness. Line segment, a part of a line with two endpoints. Ray, a part of a line that starts at one point and extends infinitely in one direction. Plane, a flat surface extending infinitely in all directions. 2. Angles. Acute angle, less than 90 degrees. Right angle, exactly 90 degrees. Obtuse angle, between 90 degrees and 180 degrees. Straight angle, exactly 180 degrees. Complementary angles, two angles that Geometric transformations are operations that alter the position, size, or orientation of shapes on a coordinate plane. There are four main types of transformations: translation, rotation, reflection, and dilation. Let's explore each one in detail with diagrams. 1. Translation. Translation moves a shape without rotating or flipping it. Every point of the shape moves the same distance in the same direction. Example, translating a triangle 3 units to the right and 2 units up. 2. Rotation. Rotation turns a shape around a fixed point called the center of rotation. The angle of rotation determines how far the shape is turned. Example, rotating a square 90 degrees counterclockwise around the origin. 3. Reflection. Reflection flips a shape over a line, creating a mirror image. The line of reflection acts as the mirror. Example, reflecting a pentagon over the y-axis. 4. Dilation. Dilation resizes a shape by a scale factor, either enlarging or shrinking it. The shape's proportions remain the same. Example, dilating a rectangle by a scale factor of 2. Properties of transformations. Rigid transformations. Translation, rotation, and reflection are rigid transformations because they preserve the shape and size of the figure. The image is congruent to the pre-image. Non-rigid transformation. Dilation is a non-rigid transformation because it changes the size of the figure. The image is similar to the pre-image. Coordinate rules for transformations. Translation. X, Y / right arrow, X plus A, Y plus B. Rotation. 90 degrees counterclockwise, X, Y / right arrow, YX. 180 degrees, X, Y / right arrow, X, Y. 270 degrees counterclockwise, X, Y / right arrow, YX. Reflection. Over the x-axis, X, Y / right arrow, X, Y. Sure. Let's dive into the concept of rotation in geometry with detailed explanations and diagrams. What is rotation? Rotation in geometry is a transformation that turns a figure around a fixed point, called the center of rotation. The amount of turn is specified by the angle of rotation, and the direction can be either clockwise or counterclockwise. Key components of rotation. Center of rotation, the fixed point around which the figure rotates. Angle of rotation, the measure of the degree to which the figure is rotated. Direction of rotation can be clockwise or counterclockwise. Rotation rules. 90 degrees counterclockwise, X, Y / right arrow, YX. 180 degrees, X, Y / right arrow, X, Y. 270 degrees counterclockwise, X, Y / right arrow, YX. Example 1, 90 degrees counterclockwise rotation. Let's rotate point A3 to 90 degrees counterclockwise around the origin. Original point A3 to. Rotation rule XY / right arrow YX. New coordinates -2, 3. Example 2, 180 degrees rotation. Let's rotate point B4 -1, 180 degrees around the origin. Original point B4 -1. Rotation rule XY / right arrow XY. New coordinates B-4, 1. Example 3, 270 degrees counterclockwise rotation. Let's rotate point C-2, 5, 270 degrees counterclockwise around the origin. Original point C-2, 5. Rotation rule XY / right arrow YX. New coordinates C-5, 2. Rotating a shape. Let's rotate a triangle with vertices A1, 2, B3, 4, and C5, 2, 90 degrees counterclockwise around the origin. Original points: A1, 2, B3, 4, C5, 2. Rotation rule XY / right arrow YX. New coordinates: A-2, 1, B-4, 3, C-2, 5. Properties of rotation. Distance preservation. The distance between any 2 points in the figure remains the same after rotation. Angle preservation. The angles within the figure remain unchanged. Orientation. The figure's orientation changes based on the direction and angle of rotation. Practice problem. Rotate the point D3-4, 90 degrees clockwise around the origin. Rotation rule for 90 degrees clockwise, XY / right arrow YX. New coordinates D-4, -3. Understanding rotations helps in visualizing how shapes move and change orientation on the coordinate plane. If you have any specific questions or need further explanations,